Now we're going to learn about the 5 different types of chemical reactions. Science takes a lot of different things and tries to classify them. You've seen classification when you've studied some life science, so you know that we classify animals as far as, and there might be amphibians or reptiles or birds or mammals, and so we classify different types of animals. We classify different types of trees. We have deciduous trees that lose their leaves, and we have evergreens that do not. So scientists do a lot of classification of things, and so when we classify chemical reactions, we're just separating them into the different types of reactions as far as what they're doing and what they're forming. So the first type of chemical reaction is called a synthesis reaction. And if you know what the word synthesis means, or what it means to synthesize something, what it means is you're forming something, you're making something. And so in a synthesis reaction, we're going to take 1 or 2 or 3 or 4 different types of things, and we're going to form something brand new out of all of them. And so when you're looking at a reaction and trying to determine what kind it is, the thing that you want to notice here is that a synthesis reaction is only going to have one product. That's how you're going to know it's a synthesis reaction. So let me show you an example. If I take carbon dioxide and I combine it with water, I can form something that's called carbonic acid, and it has a formula H2CO3. Okay, so I took 2 things on this side and I put them together to form something brand new, but I just have one product on this side. So this is a synthesis reaction. All right, another example of another type of reaction is called a decomposition reaction. You probably are familiar with the word decompose. If something decomposes, what does that mean? Well, if it decomposes, it means it breaks down, it decays, it rots. And so you take one thing and you break it down into a whole bunch of different types of compounds. Thankfully, we have a lot of fungi and different bacteria that will take the dead leaves and the animals that die, and then it takes those things and it breaks those things down to put the nutrients back into the soil, so that then we can use those things, or plants can use those things to grow more food to sustain what is still living. So decomposition is a very important part of what happens in our environment all the time. A decomposition reaction is what happens if I take one reactant and I break it down into a number of products. So when you are trying to classify reactions, what you're going to see here is that there's only going to be one reactant, and it's going to break down. So as an example, if I take water and I run electricity through it, I can actually break it down into its components, hydrogen and oxygen. So as you can see here, here I was forming something and I had one product. Here I have one reactant and I'm breaking it down into something different. So in reality, synthesis and decomposition are the exact opposites of one another. Okay? Third type of chemical reaction is a single replacement reaction. And the way I like to think about this one and the next one really too is if you've ever watched, one of my favorite movies is The Sound of Music. And in that one scene where Maria is outside on the patio and she's out there with the kids and they're watching all of the dancing couples on the inside, and the one little boy comes up to Maria and he says, "Teach me how to dance." He wants to know how to do the dance that they're doing. And so they are out there dance. She's trying to teach this little boy who's maybe 10 or 11. She's trying to teach him how to do this very complicated Austrian folk dance. And then the children's father comes out and he sees this going on and he's like, "Oh my goodness, this is sad." So he comes out and he taps the little boy on the shoulder and he says, "Please allow me." And what happens then is that the little boy, this is what's supposed to happen in a dance anyway. If one man taps another man on the shoulder and says, may I cut in, then the man who's dancing with the woman backs up, and then the other one steps in and takes their place. So that's a single replacement. We've replaced one gentleman with another gentleman, and they're going to come in and dance with this lady. So that's really what's happening in a single replacement reaction. So if I have a reaction where I have zinc reacting with hydrogen chloride, what happens here is the zinc comes up and he taps the hydrogen on the shoulder and he says, "May I?" The hydrogen, because he is a perfect gentleman, says, "Of course you may." He steps out of the way. The zinc comes in and takes his place. So then on the other side, what I have is zinc chloride and hydrogen gas. Okay? Now, in order to balance that, I'm going to have a 2 on this side. But you can see what happened here. The hydrogen and the chlorine were together. On the other side, the zinc and the chlorine are now together. The zinc was by itself, now the hydrogen was by itself, and if you analyze what happened, you can see that the zinc and the hydrogen just switched places. So that is a single replacement reaction. Okay, now we're going to have a double replacement reaction. And a double replacement reaction is similar to if you're square dancing and the guy who calls out, who's doing all the calling of all the positions, says, "Everybody change your partners." Well, if you change partners, that means, you don't end up with, the 2 girls dancing together and 2 boys dancing together. You completely switch partners, and so that the boys and the girls are all switching everything up. And so you end up with different partners than you had at the beginning. And so that's what's going to happen here in a double replacement reaction. So if I have NaCl plus CaBr2, and they completely switch up. Now you'll recall that what happens is that when I make these kinds of formulas, the sodium and the calcium, because they're both metals, they're positively charged, and the chlorine and the bromine, because they're nonmetals, they're the ones that have the negative charges. So it's your positive ones that are going to switch places. So the Na is going to be with the Br, this positive and this negative, and then this positive is going to go with this negative. So this calcium is going to go with this chlorine, like this. And then in order to make that balance, I'm going to have to do that. Okay? So again, on this one, double replacement, because I have, instead of just one thing that switches out, the sodium and the calcium both have new partners now. So the sodium's now with the bromine, the calcium's now with the chloride. Okay, double replacement. Okay, and finally, last type of reaction is a combustion reaction. Combustion, a lot of times we think of combustion meaning fire, and a lot of times it is a fire. We think of fuels burning, and so here with a combustion, what absolutely do you have to have in order for a fire to take place? Well, you have to have oxygen. You're not going to have a fire happening without oxygen. You can't have fuel burning without oxygen. So a combustion reaction is going to have oxygen as a reactant in order for this reaction to take place. And so that's going to be a key to knowing that this is a combustion reaction. So combustion, let's see, CH4, which is methane, plus oxygen. When methane burns, it ends up with carbon dioxide and water. And these are all very common products when you have a combustion reaction. A lot of times you are going to have carbon dioxide and water that are formed if you've got a carbon-containing compound on this side. Now you can also have something like magnesium that's going to react with oxygen, and that would be considered a combustion reaction too if I have a metal reacting with this, and then it's going to form some sort of a metal oxide. That would also be considered combustion. And some of those you could even consider them to be a synthesis reaction as well. So let me show you an example because I'm probably going to confuse you otherwise. let's say that I took magnesium and I reacted it with oxygen, and I would form magnesium oxide, and so to balance that I would have to do this. And so this would be classified as a combustion reaction because one of the reactants is oxygen, and I'm going to form a metal oxide out of it. If you look at this, what else could that be classified as according to some of the other types of chemical reactions that I have there? What else does that look like? Well, if you said synthesis, that would be correct also because it has only one product. So once in a while, you could have a reaction that actually could be classified in two different categories, especially if it's a synthesis and a combustion together and you're reacting a metal with oxygen. So this is a reaction that when I was still a little kid and people took pictures, they didn't do it with their cell phones all the time. We actually had cameras, and you had to put a flash bulb on the top in order to create this flash. And so what was included in this little flash bulb that you put on top of there was little strips of magnesium, and then when you expose those to oxygen, they just make this bright flash because they're actually burning. And so that is what this reaction is. So I'm showing my age there just a little bit because you guys are going, flash bulb? What's a flash bulb? Anyway, so we've got 5 different types of reactions, and so your assignment today is going to be to look at some of these reactions and try to figure out exactly what type of reaction they are. So see what you can do with that.